Welcome to this video on calculating enthalpy change experimentally. Now, typically we use a neutralization reaction when doing this experiment, as it's one of the easiest experiments we can do. There's going to be a lot of writing in this video, so just note down the experiment and try to memorize it. Now, before we get started with the actual experiment, I want to introduce you to a formula to calculate enthalpy change. So, to calculate enthalpy change, we first need to calculate energy change for the whole reaction. And to do this, we use the formula where Q stands for energy change, M stands for mass of solution, C stands for specific heat capacity of water, and delta T stands for temperature change. Essentially, what we are doing in this practical is called the calorimetric method, and it involves mixing two substances and measuring temperature rise. So assume in this reaction, you want to work out enthalpy change of a reaction where you mix a solid with a solution. So how would you do this? So the first step would be to put a polystyrene cup in a beaker. We do this to provide the contents to be mixed together with insulation and ensure heat doesn't escape. Using a volumetric pipette, measure your solution and transfer into the polystyrene cup. Then, immerse a thermometer in the solution and clamp it into place. Measure the initial temperature of the solution every minute for 2 minutes. Meanwhile, measure the second reagent using the appropriate apparatus, e.g. weighing scale. At the third minute, transfer the solid into the polystyrene cup. Then stir using a glass rod. Measure the temperature of the solution every minute after mixing until you reach 10 minutes. Plot the temperature versus time graph. And extrapolate the graph back to the time where the reagents were mixed to get delta T. Now I'm going to draw what a temperature versus time graph looks like. And I'm going to speed up the process. So as you can see on this graph, we measured the initial temperature for 2 minutes, then we mixed the reagents, then measured the temperature on the 4th minute, and then consecutively until the 10th minute. Then we extrapolated the graph back to the time that the reagents were mixed. And we got this as our delta T. So this is delta T. Now let's discuss some errors that can occur in this experiment. So the first error is that we're approximating specific heat capacity, as we're assuming the specific heat capacity for the solution is the same as water. For instance, we may have hydrochloric acid, and we would have to assume that it has the same specific heat capacity as water, but in reality, that isn't the case. We're also neglecting any energy absorbed by the apparatus. The reaction may be slow, and cooling occurs at the same time as the reaction, so the exact temperature rise is hard to get accurate. What we do to counteract this is take measurements at regular time intervals. And finally, we assume that the density of the solution is the same as the density of water, which again leads to inaccuracies in our experiment. So what this then leads to is then, say we have a question where it says 25 centimeters cubed of a solution. We would then assume that that 25 centimeters cubed works out to 25 grams because water's density is 1 gram per centimeter cubed. But in reality, the density may be something else and our masses then may be completely off. So then when we use our Q equals mc delta T, we may be using the wrong mass of the solution, which then again leads to inaccurate results. So then, to summarize, that is the formula to calculate energy change. This is useful to calculate enthalpy change, which I'll show you in the next video. This is the experimental method known as the calorimetric method. And these are the steps. So make sure you're familiar with these steps and also make sure to get familiar with the temperature versus time graph. And that's the end of the video.